Welcome back to the Mob Mentality Show. My name is Austin Chadwick and co-host is Chris Lucian. And today we are super excited to have Ariel Pérez on the show. Got all sorts of exciting topics lined up, spanning from complex adaptive systems to org topologies, fast agile, culture of experimentation and learning, whack-a-mole with risk and controls, and making plans about plans to plan to meet the plan, and all kinds of madness like that if we get to it, if there's time. So all kinds of juicy stuff we're going to get to. But before we do, Ariel, do you mind giving an introduction for yourself?
Awesome. Well, thank you for having me on the show. It's been, I've been following your show for quite some time, so it is an honor to be here. So as Austin just said, my name is Ariel Perez. I am currently the field CTO at a company called Tiny Bird. I'll talk about that a little more later, but a little bit of my background. I've always been in software engineering, primarily in product and engineering, even when I went to university, way back in the day, trying to decide what to do in the New York City area. It was between finance and computer science, and I decided to go the computer science route. I started my career in financial services. That's basically where you got a job 20 years ago, and if you weren't in the Google and the Facebooks of the world that had just started, worked my way up through individual contributorship all the way up to working at leading teams and traveling around the world with that. So the beauty of being at a big company in financial services allowed me to see Hong Kong, Sao Paulo, Switzerland, Geneva, India. So I got an appreciation of working across the time zones and working with people across the world. After several years of that, though, it became difficult to try to stay at a place where you were a cost. And it was very clear that you were a cost. And I decided to move out to startups. So my first foray into startup was into the subscription commerce world back around 2012. That was a great time to learn very fast, a lot faster than I've ever learned before. And that's one of the things I've loved about startups ever since. Did that for a bit and then started consulting on my own with small companies. I built my own startup with a buddy of mine in the music technology space. So lots of interesting thoughts there on really on entrepreneurship, product and engineering at the same time. I was also a contract CTO for another subscription commerce startup. Then got to a place in my life where I needed something more grown up. At that point, I was married and about to have my first child. And what I like to tell people is like equity doesn't buy diapers. So decided to move back to a big company for a lot more benefits, but it was pretty awesome because I got to work at massive scale at one of the largest banks in the world, working on mobile app development, web app development, and primarily in the core engineering aspects of that. That's what got me first into the idea of experimentation, building our own experimentation platform there. So lots of awesome ideas there and getting it for real at scale very fast. That moved me into to move to the UK with my family for a few years to launch a bank from scratch as a mobile app only proposition. That was very interesting, trying to build an incubator within a massive company. Then moving back to the US, ended up going to another startup yet again, and this time as the VP of engineering for Split Software, which is one of the most recent places I was at. So we can talk a little bit about experiences there and building teams and merging teams and flipping conventional wisdom on its head and why that was great. And that's when I was really following you folks. So a lot of things that I got to apply there. So I was very thankful to have this channel. And then most recently, switched over to my first role that's not engineering, which is as a field CTO. And we can talk about what a field CTO does and how that's different from a traditional CTO. And with that, I've moved to Madrid. So now I'm living in Madrid. And I'm speaking with you folks. So, that's a quick view of, what I've done, where I've been, and the kind of things that I've done. But the core of it is I've always loved engineering. I've always loved building things. And in any role that I'm in, I like building things. And obviously, when you're building things, complex things, you need to build things with people. So you need to work with people.
Fantastic. Super, super cool. Yeah, thank you so much for sharing that background. And I've been 15 minutes from my current location my entire life. So very different, than from you getting all over the place. And it's really cool to hear about your background. It's kind of more similar to Chris's perspective from kind of the leadership perspective. And so kind of coming from that perspective, what are your thoughts on complex adaptive organizations, topologies, and even fast agile? What are you thinking here?
And I think so. It's interesting when people approach software development, right? And software in particular. And historically, we've always looked at software as manufacturing, and you apply so many concepts, so many ideas and thoughts from manufacturing. The problem is that in manufacturing, you do a lot of design up front and all kinds of, experimentation, testing, validation, prototyping, but then you create the thing and you just build it over and over and over and over again. and you optimize for that thing, for creating a million widgets after creating the first one. The problem with thinking about software that way is that software is almost all the time, not always. Sometimes they're very simple, straightforward things in the software space where you're not building something complex, but I've rarely found that. And software has to be the other way around, where 90% of the work is design, thinking, figuring it out, finding out what works, what doesn't work, and then trying to build the thing and code the thing and ship it and make it run. And where complexity comes in, and we might go down a whole route of talking about complexity theory, Cunningham, and all this other stuff, right? But maybe get wonky if you want to do that, is that complex things are things that have lots of moving parts, and you don't know how moving one thing affects all the other ones, and you can't really predict it. So in that world, you have to work differently. You have to think differently. So if we accept that software development is complex, what's the best way to actually solve complex problems? Based on everything I've found and everything I've read and the experiences I've had, is you must also be complex so that you can move around and shape your way around the complex problem. You cannot attack complex problems by having a simple and definitely not a complicated structure.
Right. Yeah. So in a lot of, I guess, more traditional environments, you get, everybody's optimizing for predictability, right? But in an inherently unpredictable system, that predictability, introducing predictability, can even be damaging to progress and things like that. Have you seen things like this, or is there, you had a large variety of experiences. How has this thinking played into your variety of experiences?
It is interesting. In every org I've ever been in, there's this quest for predictability. Sometimes it's been frustrating that even from the engineering leadership, they're like, I must be predictable. It's like, but you've done this job and it's not predictable. Yet now that you're in the leadership position, because of the pressure I get from the CFO or the CEO or the COO, the rest of the C-suite that doesn't seem to understand how software works and why isn't it like every other part of the org? It gets sometimes challenging and frustrating where your engineering leadership is also asking you for predictability. And you're right. I think in a complex world, you cannot be predictable because you don't know what's going to happen next. And it's really hard to say that, right? It's really hard.
Right.
Well, it's hard to say it on one side, right? Because you don't want to lose credibility that I don't know what happens next. I can try this, I can try this, I can try that. I can give you guidance, principles, ideas as to where I'm going, when I know I'm going to stop, when I believe I know I will have solved the problem, but I can't tell you when because I do not know. And if I do, I'm lying to you, and I don't want to lie to you. And that's hard to say, right? Because you feel you're going to lose any credibility. And on the flip side, it's hard to hear because people want a date, people want to ship, people want to know when they'll have the thing so I can sell the thing and plan around it, right? But the interesting thing about it is, and this is a question I've asked folks, and they kind of squirm a little bit when they have to answer it, which is this: what happens if we don't hit that date, right? and it's really hard for people to answer. It's like, well, we just can't miss it. Why can't we miss that date? Then they might go around some paths on, well, it'll affect the revenue model, it'll affect the projections of like, yeah, but really what happens? How many customers are we going to lose? How many customers are going to be affected? What things are going to break? What big problems are going to occur? And very rarely can they come up with an actual real answer other than, well, I need to give you a date because without a date, you're not going to do the thing. And how do I keep the team motivated? And then for me, a kind of person that believes in people and believes in intrinsic motivation, and that generally, especially engineers, we want to do good work. It's a very challenging and frustrating thing to hear that you must slap dates on us because that's the only way you keep us accountable. And it's the only way you keep us moving. And I can understand why that comes, right? I can understand that theory X view of the world and that lack of being positive about how things work and how people work is just very frustrating and challenging, and actually becomes demotivating.
Right. How do you manage that? So, it sounds like you've been at higher levels of organizations and you're bridging the gap between, the leadership asking for predictability and the engineers asserting non-predictability. So how do you are you like Spider-Man holding the two pieces of web with the bridge crumbling between you, or like what's the
It can feel like that. It can feel like, I'm holding the two spider webs and on either side and trying not to fall apart, right?
Yeah.
Because on the one hand, I can understand why the non-software folks, the non-engineering folks are asking for this predictability, right? They want to be able to make plans. They want to know when they can sell the thing. They want to know when they're gonna, outpace competitors. And that's a natural thing to expect in business as you're developing things. So I can understand where they come from with that. And I can also understand the need, especially as a leader in engineering and an executive leader, to be able to actually, with a straight face, be able to say, this is what we can plan on for the business, this is what the things we're going to do and we want to do. So I know that part of the job, and that part of the job is hard. And that part of the job has become a lot more important now after the past 2 years, or actually, not only more important, more required after the last 2 years of cuts after cuts after cuts. And engineering managers now have to kind of like justify their existence and justify ROI. On the other side of it, it's, how do I talk to my engineers and say, I am one of you. I am not the ilk of leader that cracks the whip and says, ship, ship, ship without understanding what you're doing. I'm in the trenches with you. I'm coding with you. So I think the key piece to navigating that is, especially in today's world, in this market, that you will not, as an engineering leader, you will not get leeway to push the envelope and say, give me some space to be a little bit less predictable unless you actually have accomplished something. You need to deliver. And you need to deliver something. And we'll talk about what that something is, but you need credibility in order to then buy yourself space. Now, often as a new leader, you get some leeway. You have to figure out how to use that leeway as a new leader. But once you're in there, unless you've actually built a track record, you've probably lost that battle. You're not going to be able to do that. So then the question becomes whether, when you're a new leader, you have a very short period of time to learn about your organization and figure out where they are, where they're going, what they're doing, to get them to that place where they can buy themselves the space to not have to be predictable. So what do you need to not be predictable? You need to ship early, you need to ship often, right?
Yeah.
The interesting piece is that once you ship early and you ship often and you're getting those really fast feedback loops, generally that question of predictability melts away because you're constantly attacking the problem and constantly learning and constantly delivering value and very quickly pivoting. And then that breaks back down to, like, what you folks love in a spouse, which is a big aspect is mob programming, and is one big piece of how do teams get really good at shipping early, shipping often. That's not the only piece, right? But I think that's the core piece, that I use my power and my level to ask the executives, I need some time and this is what I'm doing. And I know I only have a certain amount of time. And then I work with my engineer saying, this is how much time we've got. Otherwise, if we don't get this stuff right, you're going to be stuck in that world of Jira tickets and managing tickets and being told what to do. Which one do you want, right? I really don't want that. I don't think you folks want that. So let's work together to figure out how to get to become a tip top, top shape engineering organization that delivers early, delivers often. And it might require you to change the way you work, change a lot of the things that's been beaten into you that you think are the things that engineers do. And let's figure out how to not do those things, because otherwise you're never going to do the things you're going to want to do. You're always going to be having to be accountable to deadlines and schedules and timelines and Jira tickets, et cetera, et cetera.
Yeah, I don't know any developers that wouldn't be motivated by the prospect of not having to use Jira as a motivator.
Nice, nice. Yeah, and I think, and I wonder, you kind of talk about being Spider-Man and the kind of communication bridge, so to speak, between theory X and theory Y. And I think the confusing part is there's different kinds of predictability, right? So if you have something like, kind of you hinted at there with like mob programming and continuous delivery, you're going to be very predictable in one sense, right? Like if you have happiness going on multiple times a day, there is a new release, whether in a production environment or production-like environment. And so experimentation and delivery is happening constantly. So that is very predictable. However, for fixed scope, fixed date predictability, that's, like you said, you're in the unknown space here where you're feel pressured to lie about the future or guess, right?
Yeah, I mean, well, here's the interesting thing, right? Fixed scope and fixed date. I don't know about you guys, but I have rarely ever been in any project where the scope was truly fixed and or
Right.
the date was truly fixed. This is and even going back and having started in traditionally truly waterfall places, we know everything there is to know about this thing, and this is exactly what we're going to build, right? And then we're going to estimate that it takes this much to build it by this date. We've known that that's never true. We've known that unless it's a very simple thing that a million people have done before, right? Which doesn't happen very often.
Right.
um, we know that that scope is wrong because you cannot guess and plan the world ahead of time, and that scope's going to change even after the first, after the first, encounter with the enemy. In this case, no, with your partners, with the customers, with the value. Your first encounter, it's going to change. So fixed scope is not real. It doesn't exist.
Yeah. Yeah, you're right. And I think maybe it comes back to what you were saying earlier. What happens if your fixed scope, fixed date thing doesn't happen? And unless there's like a true business driver, and sometimes there is, but often, like you said, it's kind of theory X looking for a foothold to externally motivate with
Exactly.
deadlines, right?
Yeah, and
And
using
so,
the deadlines to really, like a cudgel, and really forcing the
yeah,
team, you must meet this
Yeah.
deadline because
right.
that's the way they only feel. That's the way that certain folks feel. It's the only way to maintain pace. It's
Yeah,
the only way to keep energy and movement. Now, they don't realize that the flip side of that is I'm sorry, or the one of the consequences of that is that while you do that, you lose respect and trust from the team itself. You lose any kind of I think the trust is huge, right? That you're not looking out for my best interest. So why would I give you my best? And why would I tell you when there's a problem? Why would I tell you when there's an issue? So you start hiding problems, hiding issues. You start cutting corners left and right to try to hit that date.
yeah,
Usually the corners that get cut are the things that enable quality, ongoing quality, are the things that then bite you in the rear the next time you need to build something here. It's twice as slow, maybe not twice as slow, but you keep cutting these corners, not building quality in. The next thing is 3 times as slow, 4 times as slow. And then you've got that same business asking, why are you guys moving so slow? What's the problem? Why are you guys talking to me about tech debt? So, and all this tech debt and stuff. So, those are some of the consequences that happen when you keep cracking that whip and don't give the team the time and space to step back and understand what's going on. Um, so yeah, it it's frustrating. It's frustrating and challenging, and it's really hard to spend this time and try to talk to folks about like
Hmm.
this is what's happening, and they say, yeah, yeah, I see it, I understand it, and then nothing happens anyway, and they keep
Right.
going because it's the only thing they know.
Yes, 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 yes. Maybe before we transition topics, I wanted to ask you one follow-up question, which was you said earlier to handle complex problems, you need to be complex yourself. And
Yes.
what comes to mind is like, ooh, I need to be sophisticated, maybe a monocle, maybe put on a top hat. Like, what does a complex, sophisticated developer look like to handle complex
Got it.
problems? Yeah.
So, I mean, I think the idea of complex adaptive is,
Uh-huh.
when the interesting world is, when you look at nature, right? In nature, and you look at, a flock of birds flying, right? And, what is it? Starlings moving around. You see how that entire amorphous blob moves all around, and it's unbelievable how none of them crash into each other, right? And the way they move. Other things about nature that nature figures out ways to grow and change based on how the environment is changing because it's a lot of small pieces all fitting together, and then those small pieces fitting together at a macro scale have some kind of behavior, some emergent behavior from that system of those movements. So what is great about that, and how do you apply that to the way you're managing an engineering organization? You know, for a while, people were talking about fixed teams, stable teams, and there's a lot of validity there's a lot of positive aspects of having a fixed, stable two pizza team, right? The two pizza idea is, well, if you don't have too many people, it's really easy to manage the relationships with each other, build those relationships, understand who's doing what, right? And if it's a fixed team, you do all the forming, storming, norming, and performing. So all that stuff is awesome for building a team and really creating cohesion and people that can fly far. You can trust each other. These are your comrade in arms. The challenge about fixed teams is that often the work that comes at us, especially complex work, doesn't care what size my team is. The work itself might be bigger than the team. The work itself might be smaller than the team. So now if I'm an organization, I'm a head of engineering, and I've got my 5 teams because I've got my 5 product lines, and this is what you do. You create your teams. What happens when team 2 has a lot less work than team 3, and then team 5 is overwhelmed because the goal there is much bigger? And let's be actually very generous, where it's not that product's trying to force a lot of work down that team's mouth, and this product is not giving them enough work. It's the market is telling you that this is where we need to invest. This is what the customers need. What do you do, right? In that world, you either cut the scope to make the team, be able to keep with the scope in that area where you should be investing. That's a bad business decision. You're not investing where the market is taking you. Or you might end up reshuffling people. Let me move just these people and help over there. Or let me figure out how these people line up. So you start doing things to break that whole fixed team pattern. But you said that's the best thing to do, maintain fixed teams. So if you think about how to make a complex adaptive world, one of the things to do is, you know what? Forget those team boundaries. Merge those teams into a bigger team. Now, this breaks that concept and that idea that teams should be 6 to 9 people. You can have a team of 20 people, 30 people, 40 people. Now, what would you do with a team that large, right? The idea is that within that team, that macro team, you have all the skills, all the capabilities, and all the things you need in order to get the work done. So now, instead of the work adapting to the team adapts to the work. So if you have that big piece of work, well, you carve out a meta team out of that bigger team to say, go attack that work. And then you have a small piece of work, another small meta team branches off and carves that work. And when that work gets done, those people fold back into the bigger team. So it's a team that amorphously and dynamically adjusts to take on a 2%. They become 2-person teams, 3-person teams, 5-person teams. What's the value of this? You can regularly adapt to the scale and scope and size of the work that's coming at you. And if more things are important, you do that. There's also other benefits. You get a lot of cross-learning happening. So you build that knowledge base. You tear down knowledge silos because the entire team starts learning about all these things. And you end up having a lot of intermixing of skills and building of skills. What are the things, but then you also need to do certain things to maintain that, right? Mob programming becomes spectacular in that world because you have a small pair, you have a mob here, a mob there. So you start creating almost like fractals, that the complex and massive group is learning from each other, but the little groups are learning from each other, and then the smaller groups are even learning from each other. So you create this amazing virtuous ecosystem that there's constant learning, constant sharing of information. You reduce bus numbers, you reduce dependencies, right? If you have those 5 teams, imagine when those teams depend on each other and they have to do this massive sequencing diagram to figure out and play Tetris on how to get the work to work. When you have these bigger teams, you actually have less work. And one last thing actually also happens from that. You end up reducing work in progress, or you force yourself to reduce work in progress. So you also reduce, some of these dependencies. So, I'm going into a bunch of different things, but these are a lot of the things that, one, I saw in the theory, but also that I saw in actual practical application. These are the benefits that I saw from creating a larger macro complex adaptive team. We adapt to the work at hand, not the other way around.
Fascinating. So without using the word FAST framework, it sounded like you described it. Is that right?
Yeah. And I got inspired by it.
Yes.
There was a few things. I saw folks talking about fluid Scrum. I saw people talking about FAST Agile. I remember I had been in the Spotify model. I had done a version of less, and all those things seemed like not the right thing. But when it came across fluid Scrum and it came across FAST, I was like, this is the thing I've been looking for forever. Like, this is the thing. And then I said, hey, team, let's try this thing. And interestingly enough, I connected to the folks in the FAST community who were building it. I was one of the early teams to do this stuff. After they had the initial intrepid teams that created this thing, I was one of the first teams that was doing it. And it was great, kind of like having a set of principles, but my team working out how to do this and how to build this. And yes, we did FAST Agile or fluid scaling technology. The name has adjusted and changed, but that's what we did. And the team hated it at first. At first, this is a wild world. Like, why aren't we doing Scrum? Why aren't we doing fixed teams? Why are you merging all of us? But a few months in, they didn't ever want to work any other way. And this, they loved it. And the bus numbers were gone. The dependencies were gone. The cross-learning was there. Adapting to any problem that ever came was there. It was amazing seeing that happen.
Oh, cool. Yeah, it's really fun to see, hearing you drawing from your experiences of doing it, because even it sounds somewhat similar to us in one regard, because even though we never were like and correct me if I'm wrong, Chris, officially followed the FAST framework.
Right.
We basically discovered we've been operating in that way, at least to a large degree, at least in principle, I think, for quite some time, in parallel to the people, Quentin and all them, where there is a kind of a larger team, so to speak, that dynamically can shift and adapt to fit the work. Even if we didn't follow all the same ceremonies that they did, exactly. But I think it was the same spirit of it. Yeah. Cool. And I guess that ties right into building a culture of experimentation and learning. So,
Yeah.
yeah, what are you thinking here?
I think there, I mean, well, the world, when we talk about the world of software and how fast things are moving, right? Not only software moving, business is moving really fast. The world itself, accelerates in how fast it's moving. And when it comes to this idea of building a culture of experimentation and learning is that we need to get really good at learning, right? And we're not just a building, not just a developing, like we need to figure out how to learn faster because our customers are expecting more of us. We don't know what our customers want. We don't know exactly what they want. So we have to learn from our customers faster. We have to learn about each other on the team faster. We have to learn about the business itself faster. So basically, everything we do in terms of how we organize ourselves, how we work about the work, how we plan the work, how we do the work, but also the things we deliver, the customers themselves, the market, we just have to optimize for learning. We have to optimize to figure out how to get feedback on a regular basis and ingest that feedback, digest it, and figure out, and then come up with knowledge out of it and say, well, what did I just learn and how do I apply this learning? Well, number one, how do I verify that this is what I learned and this is true? And then take that and go forward and continually do that over and over and over again. Because at the end of the day, right now, is like we know nothing. We think we know stuff, but we don't know anything. And something that worked over here will not work over there. So we have to take almost always a test and learn approach to pretty much everything we do.
How, I guess going into a new team, how do you encourage experimentation? Or have you ever run into it where experimentation was stagnant and, or maybe they always succeeded or always failed, maybe the balance of success and failure was off or something. Is there any strategy that you have there?
Well, there are a few things, right? There is, and I'm gonna break it into two camps. There is experimenting with how we work, and there's experimenting with the product itself. And the approaches are slightly different, and they have different, and the technology and tools and processes are different, but the approach is the same, which is, hey, we think we know. Well, you diagnose whatever the problem is, right? And as a team, let's say we're going to try something new, and it's amazing when you talk about historically, like retrospectives, right? That's kind of the spirit of retrospectives, right? What are the things we've seen? What are the things we've learned? What are the problems? What's going well? And well, going forward, what are we going to try? But I think to be an experiment, there's a few things, especially when you're trying hard things and difficult things with a team. You introduce things as an experiment, and an experiment has a few things to it, right? You have a hypothesis. We think that this change is going to result, changing this, applying this change is going to result in this outcome. And then there's a second piece, and we know that we will reach that outcome when we see these results, these particular results, these particular metrics change, these particular behaviors change, these particular things improve or get worse. And we expect to see it within this time frame. So the awesome part about that, which is we're going to try something and we'll know it works when we see this, and it's going to be for this amount of time. The great part about that is even if you're trying something brand new that might seem painful to certain people in the team or might seem like out of the ordinary, if you give people a deadline or something to look forward to, they know this isn't forever, right? So there's a big piece there. Look, what's the worst that can happen? Let's try this for a month, right? Worst that happens, you hate it, and after a month, we don't do it anymore, and we're done. Best thing that happens is this is amazing. This is the best thing ever. We tried something new, right? So when you couch things in those terms, you often find that even the most reticent people and the people reluctant to apply a change will do it because they know there's an end in sight. Now, that's on the process and organization and team side of things. And that can happen at any level of a company. Then there is experimenting on the product side, right? And that product thing is we don't know if the customer is going to love this or not. we don't know if it's going to do the thing we think it's going to do. We can do all the research, all the design. We can do, user studies. We can do, we can try to validate internally, but until it's in front of customers, we don't know. So what does that do to your engineering organization? What does that do to how you develop products? It's what is the minimum amount I can invest in this thing to get that feedback soon, to know that I'm wrong or know that I'm right. But that doesn't mean build crap, right? Sometimes we ship things that, with sticky tape and duct tape, and then it takes off and the whole thing tears apart and falls over. So there's got to be some minimum level of quality we build into the things we ship, but not try to come up with every solution, every idea, every possibility, because you know what? It might be wasted work. You might have thrown out. So how do I optimize for build the first thing that I can learn from very fast and then use that to guide my development? The other interesting piece is that we often think about this as a product problem, right? The product we can put in front of the users, but this can apply to even like low-level architectural platform side things of engineering. We think this thing is going to increase throughput by this much, or reduce latency by this much, or reduce errors by that much. We'll go and test it, put it out behind a feature flag, validate it, run an experiment, and see if the engineering decision that you had actually works. And the awesome part about this, and this is awesome about mobs, mobs do this often, is let's stop arguing about this thing, just code it, right?
Yeah.
Just code it and ship it and see if it works. And if it doesn't work, tear it down and rip it and rebuild it again. Same thing that happens in that cycle of inside of a mob. Just try it and code it and get it out there. We're going to spend more time arguing about it than actually doing it. Go do it and then see if it worked.
Yeah, and I think when you, especially in teams that are siloed from each other or just solo developing, and those arguments can just go on, right? And in a mob, it's very easy to either flip a coin, do both, go with the least experienced voice. Like any of those strategies can really move things forward. But having a mechanism to quickly disagree and commit, I think, is really important, for sure.
Yeah. And I think the thing that helps to disagree and commit, at least, and for all of these, is like, how bad can it be? How wrong can you get it? Right. And
Right.
this is often asked to like, how wrong could we actually be? What will go, what's the worst that'll happen if we're wrong right now? And, there's things about like, reversible, irreversible decisions. Same thing there. It makes it so much easier to disagree and commit. If it's like, look, is this reversible? Then let's stop arguing about it. Just go, disagree, commit. And then if that's wrong, we'll just change it.
Yeah.
Yeah. Yeah. And I think that's the key, right? It triggered a thought in my mind when you said, how can we do feature experiments without shipping crap, right? And so I think part of let's stop arguing and do it is you need to make each experiment safe, right? So whether that's with a feature toggle or in my experience, typically you do a good job on each experiment, right? And as long as it's small, doing a good job doesn't turn into this giant thing because it's just a small experiment, right? So can we make it safe and small? And then that kind of alleviates all the pressure of you need to be right to try it, right? Because if it doesn't work, you just turn it off.
You don't know if you're right.
Yeah, exactly. Yeah. And so it either just kind of turns into a Zen peaceful game where it's just kind of like, oh, this is interesting. We'll see, if, this either collective idea or so-and-so's idea doesn't work. I've also seen it kind of have a playful banter. We're like, all right, well, I don't think your idea is going to work. Well, let's try it. And then when it blows up and no one likes it, we'll turn it off. You know what I mean? Or, like kind of this more fun style of it. Don't say that with crudeness, but, I've also seen that too, where there's some little bit of light competition on, it reminds me of some of the early stories in Amazon where an engineer had an idea to show products related to the current product in your checkout. And a VP was like, nope, that'll never work. Don't do it. And then he just did it as a feature flag, ran it on a small set of customers, showed the results, and then the VP was like, oh, I'm wrong. You're right. Let's do it now.
Yeah, but it's interesting that piece, there's so much hippo-driven decision making, right? Where, most organizations are like, no, don't do it. And that's it. That's where it stops. But there's a piece there that for a leader to be able to say, oh, you're right. You were right. I was wrong. There's so much humility that's necessary, so much, emotional intelligence necessary to do that. And that's something that's missing in so many places. And, one thing you were just saying about like, this playful banter and this like, hey, let's see if you're right, things are going to explode. in most organizations, unfortunately, that's missing because teams haven't really been built. And these, you're only comfortable having that level of banter when you really build an amazing culture with each other. Like, look, we can joke around on each other because we respect each other and we trust each other deeply, right? And we can also joke about the fact that this is going to explode in production if we build in the quality practices that say if it explodes in production, it's not going to be bad. Like you said, it must be safe. We need the ability to detect something really bad really fast and be able to shut it off just as fast.
Yeah.
Right.
Yeah, exactly. And yeah. Maybe it's a good time to transition to risks and controls. This is in a never-ending game of whack-a-mole. When I see
Yeah.
this topic, literally nothing comes to mind for me. So I'm like really curious what you're thinking here. Like with certain
Awesome.
other
I'm glad.
topics, it's kind of more like, oh yeah, culture, experimentation, learning. And this one, I'm kind of like, I have no idea what he's going to talk about here. Please share.
So, I mean, I think it really depends what kind of software you've been building, what kind of industries you've been in. So, this whole risks and controls question, like it literally rules the day and is the thing that can stop all conversation and all work in organizations that are highly regulated. So, if you're in an industry like
Sure.
banking, if you're in healthcare, if you're in government, in places where the stakes are very high, either because if you get it wrong, somebody dies, or if you get it wrong, you're going to get fined by a regulator, then risk and controls runs the place. And I think it doesn't have to be in a negative way, but often ends up becoming negative, meaning there's so many times where, and this will not resonate. You might be hearing like a flame war on LinkedIn, like, oh no, that'll never work here in this org. There's no way we can do CI/CD here. There's no way we can mob. There's no way we can remove PRs. Like we must have PRs. That often comes from a place of these things were put in place by someone who was trying to mitigate a particular risk. And then this is the control they put in. The control was, well, since no engineer can go solo into prod, PRs are the way to make sure that no one engineer can put something into prod. That's a control. That's not the only control, for that. You can find many other controls. And the never-ending game of whack-a-mole is the way I think about it, is that at the end of the day, you cannot eliminate all risks. All you do is transfer risks, right? If, for example, you say that every single release must go through a change approval board, right? And you hear companies talk about cabs, and I can't go to prod until the cab reviews my release and approves it. Well, that mitigates a risk, right? It mitigates the risk of, let's just, well, on paper, it mitigates the risk of, look, you know what? Everything's going to be reviewed. Nothing's going to production without people looking at it. People are going to ask the right questions and make sure that things are solid. You're going to present all your documentation. So that control is, effective. On paper, that's an effective control. But the thing is, when you introduce that control, you're now introducing a bunch of new risks. The new risks are, well, now if every change must go through the approval board, well, every change is going to be slow and every change is going to take a lot of work. So you know what? The transaction cost for a change skyrockets. So what I'm going to do, I'm going to do less changes. I'm going to batch my changes together. And you folks know this, the more changes you put together, the higher the risk grows that one of those things is going to be wrong, right? Or one of those things goes wrong, do I have to pull out the entire release or not, right? So now you just start creating new risks. So at the end of the day, the risk game is a game of whack-a-mole. I need to be able to define my risks. I need to be able to understand which risks I want, which risks I don't want, which risks are more important, less important. And then I ideally have to think about which controls I implement that mitigate my risks without introducing new risks that I don't want. So that's my whole idea. And for me, this was formed after working so long in banking and seeing so many times, no, you can't do that. You can't do that. You can't touch prod. What do you mean I can't touch prod? But I'm the one who knows the code, but that other guy has to touch prod. It's like how inefficient and how ineffective that stuff works. And then when I joined the new org, it was amazing where we were in an org that we had to rethink all the risk and controls. That was amazing. Being in a place where we said, we need to figure out how to go faster than everyone else, but do it safely. So how do we rethink risks and controls? The amazing part there is like, you know what? There's a lot of things in CI, implementing CI/CD, implementing automated testing, implementing self-validating systems, implementing amazing monitoring and observability, completely different way of thinking about stuff, but more effective in terms of mitigating the risks we were worrying about. Introduce new risks, right? It didn't mean that we weren't going to break prod, right? Anyone thinks they're never going to break prod, like they've never actually shipped code, right? Or anything important. It just meant that we decided which risks we wanted and which risks we didn't want. And the risks we didn't want was not being able to move fast enough to really respond to customer needs, not be able to move fast enough to innovate faster than other competitors. Those are the risks we did not want. So we had to figure out what effective controls we needed in place to not have those risks, while also take care of the fact that I want to make sure that, you know, your grandma can go to the ATM and get her money when she wants it, right? That's a big risk, and we want to make sure that we never go down. So it's just a game that you have to kind of think holistically. You have to think about the entire system. Well, you know, what happens when I take this out, or I stop this practice, or introduce this new practice.
Yeah, I love that because, you know, I at one point I was in the highly regulated, high risk software for nuclear industry, and it was very much heavy, heavy, heavy controls, right? And I think I kind of came into it at a point where it was not only a couple years worth of controls, but like 30 years worth of controls. And then I'm like day one on the job. And I remember someone drew a diagram of here's what it takes to make the most trivial software change ever. And it was like you have to go through like 20 controls, right? And I think what I noticed in those conversations of the people who were generating the controls is the conversation would stop at level one of the subsystem, right? So here's a risk, here's a control, a new control we're introducing. And there might have already been 20 other controls in place, but those 20 controls didn't, cover this problem that happened, this other risk. So we're going to introduce another control. And then that was kind of the end of the conversation for changing the process was, oh, a new risk, here's a new control. Done. But I think what you're right, you need to ask the follow-up question is, well, that control also introduces risks. Let's talk about those before we sign off on that new control. And I don't know, light bulbs went off in my head on that because I think I always struggled with how to frame the conversation in that environment because you sound like you're like, oh, it's just this risky, you know, gunslinging engineer who just wild, wild west wants to just jam things into production without care for quality or risk. But, you know, you got like you said, see it holistically, you know. So.
Yeah, and you know, one of the simplest ways to explain that, and you know, have people see it and understand is, if you make it really hard to ship software, you make it really hard to fix problems, right?
Right.
And it's funny, in all these organizations, there is the regular process and there's the emergency process, right? And the emergency process seems to work, but you know, then you know, in the emergency process, unfortunately, you just start getting rid of all kinds of guardrails, all kinds of protections. So you're actually introducing a lot more risk. But the funny thing is, the organization has a process for shipping fast. Now it's not great, it's not amazing. And imagine you can get them to flip on their heads, like, what if we made every change fast? What if we made every change like an emergency? And no, I'm not saying a million people, alarm bells, fires, and stuff like that. But what are the things we do when we have an emergency? We have a lot of people working together at the same time collaboratively and watching each other's back. You know what that looks like? Mob programming in real time. So why don't we make every change work like that? Let's make every change with all the best people looking at one thing at a time, making sure we get it right, and then automate everything to get that to prod. Every change is now like an emergency change, but you know, those orgs don't, it doesn't click until you potentially put it in that way, right? We want to make it so that we can fix problems fast all the time. So let's ship software fast all the time.
All right. That's a good note for us to call time on, because I think we're about at the end of our time box. But if you know, if you have anything to plug or share, Ariel, then that might be a good time to do it.
Awesome. Well, the thing I'd love to plug right now is, well, obviously the things I talked about is not talking about where I work right now, but you know, if you find yourself stuck in Scrum world, Kanban world, traditional Agile world, fixed teams, just think about the fact that what happened if you merge those teams and you try to attack the problem by you being complex, right? There's so much out there. Imagine just working in that way for a while. It is, I think, is game changing for how you approach your work. But now plugging work that I do right now, things I'm doing. I'm in an amazing company that called Tinybird. We're a platform for building real-time data products. And the thing that, you know, our big motto is speed wins. So I really care about this fact that how do you get as an engineering team from an idea and concept all the way to a production solution as fast as possible? You can't do that without guardrails. You can't do that without tooling and things that help you. You can't do that without a simple system that makes it really easy to guide you. And that's the thing that we do. So we love working with engineering teams that are trying to build, you know, real-time low latency, high concurrency analytics applications over vast amounts of data. So, if you find yourself, you're in a small startup in a small company, or you're working on a team where you're working with something like Cassandra or Scala or DynamoDB and working low latency, high scale, but you can't do analytics, right? You can't show dashboards, you can't run time analysis information. Take a look at Tinybird, because we're building some awesome stuff there. And that's why I moved here as the field CTO. I sit with customers all day, I sit with prospects all day, I sit with the engineering team all day, and trying to figure out how we apply our work to that world. So very slightly different from my entire history so far, because I've been building stuff all along, been head of engineering. Now I'm sitting with engineering teams on what do they want to build and how do they want to build it, and try to basically think about how to make this work for them. So it's been a fun time, and I love it here. And if you haven't seen them, definitely take a look and check out Tinybird.
Awesome. All right. Well, thanks for being on the show. And to our audience, if you maybe know somebody that is working through the slow way, but they have an emergency process that is already the fast way, then maybe share this episode with them. Anything that you saw here that you agreed with, disagreed with, we love the discussion. So comment, like, subscribe, notification bell, all the things. And we'll see you all next time. Thanks for being on the show, and bye, everybody.
Goodbye. Thank you for having me.